Hello, everyone. Thank you so much for joining. We're starting right at 6 p.m. EST, and I don't know where you're all joining from, but we're hosting this from the Toronto Reactor. So thank you so much and welcome. Joining us today is Jaya Matthew. She is a senior data scientist at Microsoft, where she's part of the AI, artificial intelligence, and research team. Her work focuses on the deployment of AI and ML solutions to solve real business problems for customers in many different domains. Before Microsoft, she used to work at Nokia and HP on various analytics and machine learning use cases. She also has an undergrad and graduate degree from University of Texas at Austin in maths and statistics. So we're very excited to have her join us, and this will be a great session. We will be taking up questions at the end, so the whole presentation should take about 40 to 45 minutes, and so we'll leave the last bit of time for any questions you may have. So there's a Q&A section on the right. It's a little chat icon with a question mark in it in your top bar, if you notice that. Any questions you have, please place them in there, and Jaya will be taking them up at the end. And then towards the end, I'll also put in a quick survey link. It'd be great if I could get some feedback on what you thought the event was like, if you had any feedback for Jaya or how she speaks. We also have the live captions on, and if you want any translations, so it'll be giving you the live translations as you'd like in a couple of different languages. It is a little bit of a delay, so please bear with us. And yeah, thank you so much. Thanks, Jaya. I'll give it over to you now.
Thanks, Simon, for the introduction. So let's get started with the agenda. So this is how I've structured this talk, where we'll first get started with setting the context and defining what is this buzzword acronym NLP, natural language processing. Then to kind of motivate the talk and why we are trying to even build models is some of the common applications that we come across in our day-to-day lives. We don't even realize NLP is working under the hood in some of them. Then one of the more important concepts that you need to learn in the domain is something called transfer learning. So I'll get into that, ends up being a little more technical. So I think the bullets 2 and 3, which is NLP, understanding transfer learning, as well as models, some basics of BERT and variance. It will end up being slightly more technical. There will be links to papers in case anyone's interested in reading up a little bit more about it. So I've tried to simplify it to the best of my abilities. And next, we'll get into the applications of BERT. So once we've done those technical pieces, we get into how do we actually use it for something. In this talk, we'll handle something called named entity recognition. So that is one of the applications of NLP. Then we get into, well, if you have raw data, how do you get started with labeling it for this named entity recognition model? So we have used an open source labeling tool called Docano. There are obviously many other tools available, and you're free to use any tool for your labeling purpose. Then we get into how do you use it? Well, Microsoft and the other providers have some out-of-the-box APIs that you might be able to use. Or in the event that these out-of-the-box solutions don't work in your use case, we have some customization code, which is in Python. It's in a GitHub repository. I'll actually give you links to that and take you through some of the notebooks. So to wrap up, I'll actually give you a bunch of useful links in terms of, the various sources that I have looked into while preparing for this talk, as well as something that's useful for a beginner if you're interested in learning more about this. Like Ayman said, at the end, we should have about 10 to 15 minutes if you want to put in your questions for her, and she'll bring it up towards the end. Okay, so let's first get started with what is natural language processing. So that is the short form is NLP. I'm sure most of you are aware of it. For those of you who are not, that's what it stands for. So NLP, which is natural language processing, is a branch of artificial intelligence that deals with the interaction of computers and humans using natural language. Similar to how two human beings talk, how we talk in natural language, no coding. So it's very natural for us to talk in natural language, even to a computer. So the ultimate goal of NLP is to read, decipher, understand, and make sense of the human languages in a manner that's valuable. So when we say human languages, so we're obviously expecting this to support a text in English and all the other languages. It's not just English, you know. There are over 7,000 languages, and I mean we don't have support for all of them, but we have for quite a few now. Most NLP techniques rely on machine learning, AI, to derive some sort of meaning from human languages. So previously people had to literally have a linguist help them translate from one language to another or anything. Now we just want it all to be automated, especially because there's so much of data being generated. Throughout the entire slide deck, we actually have links to some blogs and papers and some things that you might be interested in if you want to know more about contents of the slide, as well as some background information. Okay, so now when I first think of NLP, the first thing that I think of is my cell phone. And, you know, I mean, I have an iPhone and I see the predictive text when I'm actually typing out an iMessage or on WhatsApp or an email. So you see that entire predictive text that's right above your keypad, and it tries to predict what you're trying to type next. So this is one of the, you know, applications of NLP. So it's so well integrated into our lives that we rarely even think about it. Well, not all the times is the predictive text right, and sometimes the autocorrect does annoy me as well, but it's trying to do its best to kind of save us time and make us more productive. So natural language processing is the driving force in some of these applications. So this is one of the common things that I think about when I think of where NLP gets used. There are a few more sophisticated applications. So the next one is we all use Google search or Bing search, and many a times when we start to type something in the search text box, you know, it kind of prompts us with, is this the word you're looking for, or give us some sort of suggestion. So if you look at this, here's where I was trying to search for what is deep learning. Assume I'm a beginner and I'm trying to figure out what is deep learning. So as I type learning, LE, it immediately kind of predicts and says, well, are you looking for deep learning? And then it gives me a whole bunch of other options, like, are you looking for deep learning software, deep learning AI, deep learning in education? So this is another application that we come across on a pretty much day-to-day basis. Then another one that's quite popular is translation. So supposing I'm a newcomer, I do not know French, and I'm in Canada and I want to talk to some of my neighbors, and I know the word in English is hello. How do I say hello and greet my neighbor? So here's the case where, well, it gives you the English to French translation, and maybe it's very easy for me to read the text because it looks very similar to English, but maybe I don't know how to pronounce it right. So then they even have an audio option where it enables you to speak in a sort of native dialect. So it says, well, it's bonjour. And then it also gives me suggestions which says, well, there are also other ways of saying hello in French. And then how do you use it in a sentence, and etc. Okay. So these are very common applications that we come across. Now, some more slightly more evolved applications are shown on this slide, where this is the document, marketing document, and assume you're in between meetings and you really don't have all the time in the world to read this document. So it kind of very quickly gives you at a glance that, well, the time taken to read this document is 4 minutes, and at a glance it gives you the summary bullet points of the content in the document. So if I have 4 minutes, if I have 5 minutes, I can actually go through the entire document. I don't have that much time. Maybe I can just quickly look at the bullet points and go for the next meeting. This, so the second one, the image in the center is where I was browsing through my LinkedIn profile, LinkedIn newsfeed, and I came across this one announcement about Microsoft starting something in Houston in the ION Center. And I kind of said, well, this is good news. I like it. So I say thumbs up. And then immediately it kind of pops up all these different texts, you know, like, would you like to add a comment, which is like happy to help with the setup, or it's a well-deserved news, or you know, I think this is fabulous, whatever. So these are all some of the other applications. Then you can also customize your Bing homepage, where this is a sample where, you know, you have the latest news from your organization. Then it gives you all the different meetings, the documents, can give you the summary and stuff like that. So these are some of the various applications. So this is not everything, but this is kind of just to kind of motivate the entire topic. So in terms of just to summarize what I've showed you over the last few slides, so we can use it for word processors such as what you saw on the phone, Microsoft Word, Grammarly, to check grammatical accuracy of text, SMS, next word prediction, language translation. We saw one of those with Google and Bing Translate. Then personal assistants such as Alexa, Cortana, Siri, OK Google also uses it. Then IVR applications in call centers also helps route our calls to the right agent. So these are some of the various applications most of us come across in our day-to-day lives. Okay, now that we know what is NLP, we get into what are the standard NLP tests. So the NLP tests can be split into two major groups. One is natural language understanding, and the other one is natural language generation. So natural language understanding is where our named entity recognition comes in. So some of the other natural language understanding tests are text classification, sentiment classification, question answering, sentence similarity, entailment. Natural language generation is the entire translation from English to French, or summarization all comes into natural language generation because it's actually generating some new text in a different language or same language. Now, the focus of this talk is, like I said, natural language understanding, specifically named entity recognition. So now, I don't know if everyone's aware, but we'll first get started with defining what is named entity recognition. So again, bunch of acronyms. Named entity recognition is often, you know, just you know, people just say, do you know how to do NER? What is NER? So that is named entity recognition. So it is the task of tagging entities in a text or a sentence or a corpus into different classes. So it could be a person, it could be a location, it could be a name of something. And then essentially, so this is, what is that? An example, if this is a sentence, Mark Whitney, oops, did I, one second. Sorry, yeah, Mark Whitney visited Mars. So Mars is a location, visited is not an entity, and this is a person, and this is the first and last name. So this is beginning and inside of the entity. Okay, so there are a bunch of links, as I said earlier, and if you're interested in learning more, you can actually go and read that. Okay, so then once we know what is NLP, NER, let's actually get into slightly more technical, the next two segments, but hopefully you get a better understanding of what is transfer learning and BERT. Okay, so NLP actually progressed quite a bit when the concept of transfer learning came in. So essentially, transfer learning is what you see on the left side, where the objective was to build a language model using some huge corpus of data that's available. Like Wikipedia has a lot of data in different languages, and then you have book corpus data. So essentially, they pre-trained a language model, and the language model, the one that we are going to look into, is something called BERT. And this is an entire semi-supervised step. So essentially, this is a piece that I get of the various GitHub pages, and these models get published. And I would actually use this pre-trained model from the semi-supervised step and feed it my data and then build a supervised classifier. So here's an example where my data set, I'm actually trying to classify it as, let's say, is the sentiment positive and negative. So this is one line which says the movie was good. So that is positive. Good is happy, so it's positive. The movie was horrible. So maybe this is movie reviews, and horrible is bad. So it's 0. So then essentially I have my annotated data, and then I use the pre-trained model from the semi-supervised step, build a classifier, and it helps me predict if it's a positive or negative sentiment. Okay, so now some of the things that you want to think about when you actually use transfer learning is you want to think of the fine-tuning phase. Fine-tuning is where I have the data and I'm actually using this pre-trained model. So you want to choose the right model. You have to look if the model has the language support that, so do they have support for French or Hindi or any other language of interest to you. Then you want to also read about the underlying model, the pre-trained model, and what was the data used for the pre-training task, and what was the pre-training task. So we'll get into the pre-training task for BERT, so then you'll understand how that gets built. Then model size and quality. So, obviously when the model becomes bigger and bigger, sometimes the quality increases, but then, it may not be feasible to use such a big model on an end device like a mobile phone. You want a more compact model. So these are things that you want to think about. Then you also want to think about how much fine-tuning data you have. Then many a times, since the pre-trained model was built using Wikipedia data, book corpus, the domain's very generic. So in case your data is related to healthcare or law or finance, maybe you actually need to do some domain adaptation, get data from your domain and actually train the model a little bit more. Then obviously there's budget hardware. So obviously some of these models can run for days, months, and obviously that's a lot of expense as well as carbon footprint. So we want to think about how much we're willing to spend. In terms of inference, so once you've built the model, you obviously want to deploy it into production. You just don't want the model sitting somewhere, and so that's when you want to think about the model size, quality, and then think about the latency and throughput of the model. So you don't want to actually have the text prediction on your phone taking minutes to try and predict the text. You want it to happen really fast. As well as you want to think about what is the hardware and compatibility. Now, when we think about language, so you have to think about natural language support. So there are obviously languages which are high resource. You have a lot of text in that, English, French, etc. And then you have the low resource languages. So there are more than about 7,000 languages, and we do not have 7,000 models. So, sometimes if there are models for English, French, Hindi, etc., use them. In the event it's one of the low resource languages and they have no pre-trained model, maybe you want to use one of the multilingual models. So some of them are like multilingual BERT. What they do is they have the top 100 languages, and maybe that might help solve your low resource language problem. Now, like I said, well, this is a scenario where you do not have a pre-trained model. So maybe we have to, fall back on one of the multilingual models, and multilingual BERT is available, where they choose the top 100 languages with the largest Wikipedia data corpus. So if you want to know the list of languages, here's a screenshot. It's not the entire list, but if you actually look into one of these links, it'll kind of tell you, and you can kind of look at it and see if your language of interest is in that top 100. Okay, so in terms of model size, so this is just a snapshot of 2 years and shows you how the number of model parameters has increased. So you start with Elmo, which was about just 94 million parameters. And then from OpenAI, you have GPT-1, GPT-2, and GPT-3. So if you look at GPT-1, they had about 110 million parameters. And then GPT-2, it went up exponentially to 1.5 billion. And then GPT-3, which was more recent, is about 175 billion parameters. Now, if you look at Google, so we will be discussing Google's BERT, which has about 340 million parameters, and Google came up with another model, which is T5, which has 11 billion. Then obviously NVIDIA has the Megatron, as well as Microsoft has a Turing NLG model, which has about 17 billion. So, I mean, sometimes the more parameters, the model ends up being slightly more performant, but maybe there's a trade-off and you don't need such a large model. Okay, now in terms of model, since we've looked at a few models, let's actually get into the model that we are going to look at. That is BERT. Now, the first thing is, for people who don't know what BERT is, what does BERT even stand for? Okay, again, that's another acronym. So BERT stands for Bidirectional Encoder Representation from Transformers. So as I said earlier, we are looking at Google's BERT, which has 340 million parameters. And what is that? It has a semi-supervised learning step as well as a supervised learning step. So semi-supervised, the objective is as before in the transfer learning, where you're trying to predict the mass word or the next word, and it's a language modeling. And then you have the data set, which was used as Wikipedia and book corpus, and they pre-train, they trained a BERT model. Then in the next step, I have my data set and I use the pre-trained model from this step 1 and build a classifier on top of that. So it saves me a lot of trouble because I have the goodness from this pre-trained model. So if you want to actually read about BERT, it's kind of nice to read it directly from the Google AI blog, the links provided here. Okay, so Google claims that they actually have found that BERT improves the Google search performance. So here are some examples from Google's blog, where they say that here is search by one of the users, where the user kind of searched and wrote 2019 Brazil traveler to US need a visa. Okay, so many a times, even when I type up things on Google or Bing, I mean, the sentence is not perfectly formulated, may not be grammatically right, might have typos, grammatical errors, everything. And then from this, it has to kind of decipher and give you the right link, the link to the page. So before they actually deployed BERT, so what it actually searched for was US citizens can travel to Brazil without the red tape of a visa, so that it does not actually take the context of the words in the search. So this is exactly the flip of what the user is trying to search. The user is trying to search for a Brazilian traveler traveling to the US. Do they need a visa in the year 2019? But the result was not relevant. So then you have to fine tune. So here they claim that after they deployed BERT into production, it's able to find the usembassy.gov website in Brazil, BR, visa section, and then it kind of tells you the right result. Let's take a look at one more example in here. So these are all from the Google blog, where this is where someone's looking for math practice books for adults. So I mean, me as a human, you as a human, using natural language understands this. I am an adult. I'm looking for math practice books. So here, previously, before BERT, what is that? They actually gave one of the links as an Amazon link to a math practice book for grades 6 to 8. Now, this is not obviously the right result. Grade 6 to 8 is not adult, you know? Here, after they actually deployed BERT, they were able to actually reroute the customer to an Amazon website where they have math for grown-ups. So that is more a relevant result compared to the previous one. So they claim to have quite a bit of success using BERT in Google search. Okay, so now let's actually get into what does this BERT actually do? How did it come up and everything? So BERT actually heralded this entire ImageNet kind of movement in similar to computer vision in the NLP domain. And the models are essentially pre-trained on massive amounts of data and then fine-tuned on specific tests. So this is an excellent blog by Jay Alamar, and some of these illustrations are from his blog. So he's really simplified the whole concept. Now, if you're interested in reading about this paper that brought about this whole change, you want to actually look for BERT pre-training of deep bidirectional transformers for language learning from the Google AI language team, Devlin et al. So again, like I said earlier, you have the semi-supervised learning step, and then you have the supervised learning step. So we'll get into this in more detail in the next slide. Okay, so BERT uses something called a transformer architecture. So now, if you do not know what transformer architecture is, you might want to actually go and read a little bit about encoder, decoder, then attention, and then transformer, and then this will make a little more sense. So essentially, transformer has something called layers, feed forward, network size, and attention head. So a transformer generally has 6 layers, but BERT has 2 variants, BERT base and BERT large. So the number of layers for BERT base is about 12 and BERT large is 24. So this is the feed forward network size. You can see how the size actually almost doubles from transformer to BERT large, and the number of attention heads, it actually doubles it from 8 to 16 in BERT large. So some of the changes that were done obviously is, like I showed you in here, you have way more parameters, then you have segment embedding and something called a special CLS token. So let's actually take a look at this input. So this is a sentence, let's say. So we always prefix, we start off with the CLS token. Then the sentence is my dog is cute. That's one part of my sentence. Then there's a separator token and he likes playing. So playing gets split into play and ing, and then separator indicates that that's end of sentence. So if you look at a token embedding, you have for each of the inputs, you have a token embedding. So you have E for my dog is cute, just like the previous input. Now segment embedding helps to, kind of demarcate the 2 sentences. So my dog is cute is segment A, and then after the separator, he likes playing is segment B. Position embedding is essentially the position of the input. So the CLS takes position 0 and my is 1 and the last is 10. So there are about 10 tokens in here. So you have the semi-supervised learning, and then the task used to train this huge model is the mass word prediction and the sentence following test. We'll actually look at an example of what this actually means. Okay, so like I said in the previous one, in the pre-training, they use 2 tests, which is mass language model and sentence following test. So previous approaches, if you want to read about Elmo, GPT, use language modeling tests. Essentially, that is how do you predict the next word when someone starts typing something to pre-train the model. But BERT used slightly different tests. So if you think of a mass language model, so BERT replaces 15% of the tokens. So imagine this is your input. So you have the CLS token, and this is just one sentence, which is let's stick to improvisation in this kit. So essentially you kind of mask this and have BERT try and predict it. So if you look at it, this word improvisation gets masked, all the others stay the same, and then it essentially just randomly masks 15% of the token. Then it tries to build the model, then you have the feed forward network, the softmax, and then out of all possible English words, it gives the probability for all the words, and then the highest in this case happens to be improvisation. So then you say that, well, the mask was improvisation. In this case, it's perfect. It's not always the case. Then some tokens are also, it could be randomly replaced, and the pre-training task is to predict that missing word, which was masked. Then we have the sentence following task, which is given 2 sentences. Do these sentences logically follow one another? So the input in here is the man, you've masked this word, is maybe walking to the store or something. That's sentence A. Then you have sentence B, which is penguin dash flightless birds. So do these 2 sentences follow one another? I mean, in terms of entailment. So again, you pass in the tokenized input and you have BERT do the training, you have the feed forward, softmax, and then BERT kind of looks at this and says, well, these 2 sentences are not likely to happen one after the other. So it says it's not the next one. So these are the 2 tasks in the pre-training for BERT. This is how they actually built this semi-supervised step. So now we can use BERT for classification, which is one of the common things where you're trying to predict if the, maybe an email or a text is spam or not spam. So essentially the output of this first CLS token is where you use it as a classifier to determine if it's spam or not spam. BERT network is used for feature representation of the whole sentence, and similar to the CNN architecture, this is convoluted neural network architecture. It is the backbone network for feature representation followed by task-specific network. So when we kind of say that, so BERT can be actually used for multiple tasks in the natural language understanding domain. So by changing the segment and encoding and masking, BERT can be used for multiple tasks. So here's sentence pair classification, single sentence classification, question answering, and single sentence tagging. So this is the area that we will get into more detail. So BERT also achieved, this is state of the art performance on multiple tasks in the GLUE benchmark. So GLUE is one of those list of about 8 to 10 tasks, and all these models are trying to do well on the GLUE or the super GLUE benchmark. So this is how BERT, base and large, compare on the various tasks in the GLUE benchmark, and GLUE stands for General Language Understanding Evaluation Benchmark. And if you want to read a little bit more, what are the different things in the GLUE benchmark, there's a link for that, as well as these are the results from the paper. So now with the success of BERT, what is that? It triggered a whole family of models. So this is where, BERT is what we just discussed. Then you have the span BERT, the Roberta, Albert, QBERT, Ernie, and all the different models. So this is the really cute image, and I know some of these names are all from Sesame Street. I don't know why it's from there, but yeah, this is how it is. And if you're interested, so like if you look at distal BERT, what it does is the model size becomes smaller, so it's easier to deploy in some low latency scenarios. So what is that? I'll actually give you links to all these different scenarios if you're interested. So it has slight variation in the corpus of data used for training, as well as some of the pre-training tasks, and small variance has led to a whole family of models. Now, BERT also, I think I just came across this paper the other day where some people claim that the multilingual BERT model is not as good as language-specific models in some of the tasks. So they have language-specific models for some of these languages. In case you're interested, this is the paper. And then, otherwise you can actually just fall back on the multilingual model from BERT. So this are some of the different papers if you are interested in reading about distal BERT or Albert. So that's like a light BERT for self-supervised learning of language representation, etc. So it's triggered this whole wave of research and development in this area. Okay, so now that we're done with all the technical and theory piece, let's actually look at some of the applications of BERT. So the one that we will focus on here is NER, which is named entity recognition. So let's quickly recap. So we are trying to, solve this natural language understanding problem where we are trying to figure out in a sentence, is it a name of a person? Is it a name of a location? What is the entity in there? So that helps you actually. So supposing you can figure out the entities in a sentence, you can actually have drop-down filters on your web page, etc., and kind of filter by certain keywords, etc. So here's an example. So the problem definition for named entity recognition is essentially entity extraction, which classifies the named entities that are present in the text into predefined categories. So some of the classic categories are names of people, names of cities, names of movies, genre of movies, etc. or date or time, etc. So here's a sample sentence, which is Michael Jordan's of Chicago Bull is getting a 10-hour Netflix documentary in 2019. So the name of the person is Michael Jordan. The name of the city or the team is Chicago. The name of the movie type, it's a documentary. And if you need to know which streaming service, maybe it's Netflix, year it's 2019. So you can also do custom NER where you define the entities and train your model. Now the BERT, model can be fine-tuned for NER. So essentially the label input is essentially a word level tokenization with the IOB tagging, that inside, outside, beginning. So here's a sentence where you have Alex is going to Los Angeles. So Alex is the name of a person, so it's PER. Then is going to is not an entity, so it's O. And then Los Angeles is the name of a location, but it's two names, it's two words for the name of the location. So it's the beginning and the inside. So then for each token, it's a multi-label classification task, though the classification tasks are not done independently. This is what an NER is trying to do. Now, to get started, we actually have a sample notebook where you can run this through the Wikigoal dataset, which is in the kernel format, and it uses a BERT model. So that would be one of the best ways to just try and see what results you get and see how BERT does the training and everything, using the model, and the results, etc., and what entities you get. And then you can change the input from the Wikigoal dataset to your dataset and see how it performs. Okay, so now to build a model, one of the things is you need label data. So you need that, you need to label your data. So Docano is an open source text annotation tool. So this is the GitHub, link to Docano. It provides annotation for text classification, sequence to sequence tasks. So you can create label data for quite a few things, and we are interested in named entity recognition in here. So I'll actually, so this is an animation I found on the Docano's website where they kind of show you what all they can do. It can be used for named entity recognition. That's what we're looking at, but it also can be used for some other things like sentiment analysis, etc. So now the good thing about Docano is they have a one-click deployment to some of the major clouds. So AWS, Azure, and GCP, and it's the one-click deployment, and it just deploys into the cloud. So obviously I have deployed it onto Azure because I work for Microsoft, and it is buggy sometimes, but it does deploy to Azure one click. Then I've previously written a blog on how you can, use Docano for annotation. So this is the link to the blog. I'll take you through the various steps that it's just a 7-step process how you actually annotate your data. So once your one-click deployment goes through and you log in and you first create a project. So in this case, I've said it's a demo NER project. It's a sequence labeling task, and maybe I want to run a hackathon and have different users share annotations, etc. Then the second thing is I need to upload my data. So maybe I have all the data in text format. I select the file, I upload it. The third one is once the data set is uploaded, you can see all the different pages of data that gets uploaded. Then is you need to define your entities, the labels. So in this case, this was I think some basin and economics, and this is more geology related. So this is why the labels are like this. And then so essentially it can be color coded, each of the entities. Then CB means is the shortcut is Control B. Economics is E. So I said, okay, let's have the shortcut as E, etc. Once you do that, step 5 is where your data is uploaded. These are the various labels, and then you ask people to start annotating. So here you see nothing is annotated. Here, maybe I went in or someone else, one of the geologists went in and actually annotated the data. So you see that structure is all in color code in blue. What is that? The basin is a well name or something. So you just kind of, this is annotating the data. Once everyone's annotated the data, you can actually look at statistics and all the give access to multiple users and have many users actually help with the annotation exercise. And once you're done, you can actually export the data. That's step 7. And what is that? Use it for your Jupyter notebook. So this is how you would prepare your data. Then is let's actually look at how would you quickly build an NER model. So some people may not want to go through the entire annotation and build a custom NER model. So we have some out-of-the-box APIs. One of them is the text analytics API. So this is the link to it. So essentially it does a broad entity extraction. So it identifies concepts in text, including key phrases, named entities such as people, events, organizations. So right on the website, you can actually copy paste text and then it'll analyze and say, well, one of the things is it also does language detection. So it looks at this text and says it's English. Then it says the key phrases is place, online menu, etc. And then the sentiment and everything. So this is out of the box. So if this works in your use case, it's simple. You don't have to go through any of the hassle of building the model. Well, if this does not work in your case, then that's where you think about customization, and that's where you annotated the data and you might want to use that data and use it in some of the Jupyter notebooks. So this is the repository that I was talking about, built by our team. So it's github.com, Microsoft NLP recipes. So essentially the focus is we have a bunch of different scenarios. We support a bunch of models in addition to BERT and also different languages. Yeah, some are mainly English, but there are some other languages as well. So the goal of this repository is to provide guidance on choice of models for some of the common NLP tests. So natural language understanding, natural language generation. Then it's to reduce time from business problem to implementation, make state-of-the-art models accessible to all like BERT, Albert, etc. Then there is some language support. I mean, although we say multi-language, not too many languages, but some language support. And then easy to follow examples that can serve as templates. So I would recommend just looking at the GitHub and running some of the notebooks out of the box and see if this actually suits your needs. Okay, so these are the scenarios that we have covered in here. So you have text classification. So this is the one I spoke about, named entity recognition. So the model used was BERT, and then it kind of describes what named entity recognition is, and the language supported is English. However, if you look at text classification, it's the models are BERT, ExcelNet, Roberta. Then it kind of defines what is text classification, and it actually supports a few languages, English, Hindi, and Arabic. So there are a bunch of other scenarios covered. I haven't actually, I haven't covered it in this talk, but maybe in a follow-up talk. But yeah, this is the link to our GitHub repository. Okay, so now as I wrap up, I actually wanted to leave you with a few links for you to read. So I think some of the products that we looked into were the text analytics API, so that is a link for that. This is the GitHub, the NLP recipes, which has all these fabulous Jupyter notebooks. Then Docano is the open source annotation tool. Then in terms of reading, these first four are blogs from our team about the NLP recipes repository. Then you have the Google blogs. One is where they introduce BERT. The second one is where they describe transformers, neural network. Then this is where they claim that using BERT for Google search actually helps improve the search results. This is the underlying paper on BERT. Then these are some of the, blogs I looked into. The Washington Post article, which says how many languages are there, more than 7,000. Then this is the blog where I've got a lot of illustrations from by Jay Alamar. So he has a blog as well as a YouTube channel where he does a fantastic job of explaining very, very difficult concepts. In case you don't know what a glue benchmark is, this is the link to the glue benchmark. Then you can see, well, BERT is obviously not the best performing model. There are other models that are better than the glue benchmark. So one of the things to remember about NLP models is every 6 months to 8 months, you have a much bigger model with millions or billions more parameters coming and beating the previously existing model. Then in case you're interested in Microsoft Research's work and Microsoft Turing model, this is the link for that. And if you do not know what an encoder, decoder, and language model is, this is one of the previous sessions I had done for the reactor, where there is a section on language model as well as encoder, decoder framework. If you want to actually look at this before you take a look at this one, the transform architecture. So, well, that's pretty much what I had. So now I'm actually open for questions, Ayman, if there are any questions for me.
Thanks a ton, Jaya. The only one I see was someone saying, what is a language model? I feel like you might have covered that.
Oh yeah, so what is that? A language model is essentially, think of, how do I describe a language model? It's like the input is a sequence of words and the output is also a sequence of words. So that is essentially what a language model is.
So your next question someone asked is, how do you import BERT? Is it part of TensorFlow, PyTorch, or Keras? If not, what are the relationships?
Well, it is part of, so there's Hugging Face, which actually supports PyTorch and I think TensorFlow. So BERT can actually be imported using the Hugging Face repository. So they have it, and they have just this one line where you can import the tokenizers and the model. Yeah.
Great.
I should have actually put in a link for Hugging Face in here. Yeah. So.
Okay. No other questions yet. So if anyone else is on the call, if you have any questions, please add them in the Q&A box if you can. And while you're submitting those, if you could please take the survey link, I just posted it in the chat. It lets us know what you think. So that's always appreciated. Okay, maybe we'll just leave it open for a couple more minutes for questions. All right, Jaya, so you have a question from All. Can you give an example on how a sentence is processed?
Oh, okay. Yes, I think I'll go back to one of the previous slides. I think this is here. Yeah, so essentially what we do is the sentence needs to be split up into tokens. So I think this is easier to look at it. So essentially, what is that? Your input sentence needs to be tokenized. So BERT has their tokenizers. So essentially, we would just need to give a sentence in this in a format with the CLS token separator, and then BERT has a tokenizer that you would import, and it'll actually create the token embedding, the segment, and the position embedding, and feed it into the network. So there's a little bit of pre-processing. So I would not say that processing the input for the model is easy. Yeah, I think maybe I'll just open this and I can show you that. So where is that? Did it open? Okay. Yeah, so this kind of shows you how, so you can see my screen, isn't it? Yeah, so essentially here your data set, and you actually have it kind of, for each of the tokens you have a label, then you create the PyTorch dataset data loader, so you have all these pre-processing modules already written in there, and then you train the model. So you don't actually have to write the code for a lot of these things. You have all the utilities that you're importing from PyTorch, and I think these are wrappers over Hugging Faces things. So I think what I said was Hugging Face, and that's what you might find. So here, if you look at it, they have all the transformer ones, and they support, and they actually will tell you how to do everything with BERT and everything. And then it's very easy. You just pip install transformers and you get it right there. So downloading the model, everything is very simple. If you look at Google, so then they'll kind of tell you how to install it and the configuration. So essentially you just say from transformers, import the model. So you don't have, it's quite simple.
Hi, Jaya.
Yeah.
There's one more question.
Okay.
What kind of text can it interpret? Sentence, paragraph, how long?
Is it how long?
Yeah.
Oh, okay. Okay, so what is that? So one of the things that you want to remember is it can actually, it has a sequence length of 512. So if you look at it in here, so it takes a maximum length of 512. So I think, let me go back in here and I can show you. So where is it? 1 second. I know it's right here. 1 second. So what I would recommend is, let's see. 1 second, really. It's actually 512. So essentially what I would do is, if it's a big paragraph, I would split it into chunks, smaller chunks, and pass it into the model. Otherwise, if it sees anything greater than 512, it essentially would just ignore it. So I think somewhere here I show that. So let's actually look at that. I think here. Yeah, so if you look at it, it takes only till 512 tokens. Yeah, so essentially the workaround for that is, I think there are some bigger models that takes more tokens, but I think what you want to do is just kind of split your paragraph into smaller chunks and pass it for the model to process.
All right, so a couple more questions, Jaya. How much data did you use for the NER application?
Yeah, so for the named entity recognition, so first of all, I mean, I have to admit that it's really difficult to get a lot of annotated data. So I mean, we did this Docano exercise and stuff, and I think we got about was it 200 documents annotated by experts, and we would think at least our results were not brilliant just because our data was not good. I think we should have at least about 1,000 documents to actually have representation across all the different entity types. So what we had is, in this case, was a very simple case where I think we had only about 5-6 entities. So per entity, you want to ensure that there are at least 100 examples per entity. So I think what we had is some of the entities were overrepresented and some were underrepresented. So yeah, 100 documents was not enough. So I'd say as many documents as it takes to get you enough examples for each of the entities.
Great. Another question asked, if the input is the sentence, what are the outputs?
Okay, so the input is a sentence, the output is, let me show you this, I think this will help. So input is the sentence as a token. So the output is essentially for each of the word, it'll kind of tell you what the entity is. So if you look at this one here, so here's an output. So this is a sentence. It would tokenize, and then the output is a label where it says that is it true that these are not entities. Jane is a person, so the output is it gives a label for Jane as person. Works at is not an entity, so it comes as O, and Microsoft is an organization, so it gives you the name. So it's essentially the entities, the labels are, that's what it's trying to test.
All right, and I think the last question that we have is, what are the typical functions in BERT?
What does that mean? The typical functions?
Yeah.
Oh, like what can we use BERT for?
Possibly. If
Okay.
whoever asked that question, if you could clarify, that would be good. But maybe let's go with that. What are the typical uses for BERT?
So one of them is what we did is tagging, which is named entity recognition. So sometimes you can also use it for question answering. So you can ask a question and then BERT would help you find the answer. It could be extractive, abstractive. Then it can actually classify single sentences into different classes, text classification, then sentence pair classification in the sense that is it entailment? I think this slide is one of the good ones to show. Yeah, here. So if you look at this, BERT can be used for text classification. It can be used for named entity recognition. BERT some extractive, abstractive can be used for text summarization. BERT can be used for entailment. BERT can be used for question answering. Can be used for sentence similarity. Yep. So those are the different uses of BERT. So that's a good thing. You've pre-trained it, and you just have to, fine tune it slightly differently. So can be used for many scenarios in here.
Great. And then another question that just came in. Do we have an existing BERT flavor for NER that we can use for transfer learning?
Oh yeah, so actually what is that? So this is the notebook that, what is that? So this is the one, the repository that I was talking about. Microsoft has an NLP recipes repository. If you get into examples, you have named entity recognition, and this is using BERT. So this is the notebook that would be a very good place for you to start. So kind of explains everything and how to run it, and yeah, it's all Python based.
All right, we only have about 2 minutes left. So just to clarify the earlier question where someone had asked, what are the typical functions in BERT? They meant programming functions that you can call. I don't know if that answer still applies, but.
But I kind of don't understand what programming functions. I mean, is it libraries? I mean, is that what they're asking for?
Perhaps, yeah, if you could please clarify again. Apologies for not getting it, but yeah, if you could ask again, that'd be great. Okay, well, if you do want to clarify, you can please just send us a message and we'll answer it after the call. But since we only have a minute left, Jaya, if there anything else you wanted to add or a final slide with your links if people want to find you.
Oh, yeah. So I think these are some of the links. And I think Ayman can send you the links after after we're done with the session. And that's about it.
All right, perfect. So thanks everyone. So we are recording this event. We'll have it live on our YouTube channel in a couple of days, and I'll put a link to the slides in the description there so you can check it out. And thank you so much for joining us. If you had a chance to fill out the survey, that'd be super helpful, and hope you have a great evening. Thanks, Jaya.
Thank you.